So welcome back students. In this particular video we will try to do a revision of our unit 1 syllabus, which is based on the topic of fundamentals of DC and AC circuits. So let us start. So first of all we will be starting with the basic definitions of charge and current. So how do we define a charge? It is basically a property of the atomic particles, and we know that the charge of an atomic particle can be positive, it can be negative, or it can be neutral as well. With SI units, coulomb, and symbol we are representing as Q. Then we define current as the rate of change of charge, or it is also defined as the continuous flow of electrons in an electrical circuit. Its SI units are ampere and the symbol is I. Now we have a relation that current is equal to dq upon dt. If suppose we integrate, then we can also get the value of q as I into dt, and integral is having the limits from t naught to t. Or in simple terms, if the values of current is to be calculated, we can also use the formula I is equal to q upon t. Sometimes you can expect an MCQ question where they will ask you in terms of units. So we should know, suppose current is having SI unit of ampere, then what are the SI units of Q and T? Q is coulomb and T is second. So based on the formula that we have undergone, so we can see now there is a question that 1 coulomb is same as what option is now right. So we just have to refer to the formula that I is equal to Q upon T. So we said that I units are amperes, Q units are coulomb, and T time is for second. So we can say if we are talking about the 1 ampere or 1 coulomb, it will be equal to what? Ampere into second, right? So it means the right option is D. So you should know the SI units of all the basic quantities or the basic definitions that we are studying. Similarly, you can try this simple question. The total charge is provided. It is given as 5 sine 4 pi t millicoulomb, and we are expected to find the current value at t equal to 0.5. Now in this case we can use the formula that I is equal to dq upon dt, and the value of q is already provided, so we can say it is equal to d by dt of this integral value, that is 5 sine 4 pi t, and the units are in millicoulomb, that is understood. Now what we will do is we will do the integration. So 5 will be constant, so this will be cos of 4 pi t, and we will be having a internal differentiation also, that will give us the pi I 4 pi also. So this will be equal to 20 pi, and then we will get cos of 4 pi, and because the value of t is already given as 0.5, so we will put this value as 0.5. So the value will come out to be 20 pi into cos of 2 pi. Now cos of 2 pi will be equal to 1, so the value is 20 into pi is 3.14, so it should be 62.8. Now if we see that 62.28 is given in option C also and D also, but we have to take care of units as well, as we have seen here that the units are given in millicoulomb over here, so it means the answer should be also in milli only. So the answer is 62.8 milliampere. So we should go with option number C in this case. So in this way you can expect simple questions based on current relation or the charge relation. Next we define the voltage. Voltage we define as it is the amount of energy that is required to move unit charge through an element. Its SI unit is volt and the symbol is capital V if we are referring to the DC voltage, because we follow a convention that if we are dealing with the DC circuits, we are using the uppercase letters like capital V, capital I, and so on. And once we will deal with suppose AC analysis, then we use the lowercase letters. In lowercase letters we can use small v, we can use small I, and so on. Then what we are showing over here is that the voltage, it depends on how we are measuring. Suppose if we are measuring it from point A to point B, then it is plus 9 volt, but if we are measuring from point B to point A, then it is minus 9 volt. Then the next quantity we will define is power. It is defined as the rate at which the work is done, with SI units as watts and the symbol is capital P. Now how we define power? Power is defined as W upon T if we look at the formula. So suppose we are writing power is equal to amount of energy that is done, okay, per unit time. Now what are we doing? We are simply dividing and multiplying with Q. So what I do is, if I do it something like this into Q upon Q, okay, now what this is actually, it is W by Q, which is actually available over here. W upon Q is available here, and then we have W Q upon T, okay, Q and T is left, so it is equal to like this, okay. Now what is this W by Q? W by Q is the amount of energy, because if you see this formula, what is voltage equal to? Amount of energy done to move a unit charge, means it is E upon Q. So energy upon Q is the voltage, okay. Same thing you can confirm here also. Voltage is equal to what? Joule, which is the unit of energy, divided by Coulomb, which is the charge. So voltage is E upon Q. So E and W, they are same. E is energy, W is works, and both are same. So we can write that power is equal to V into Q upon T is what? I. So we get the relation that power is nothing but the multiplication of current and the voltage. So energy already we have covered previously in the formulas as W. It is the capacity of doing work with SI unit as joules and symbol as E. Now we have certain basic things again, like resistance. How do we define resistance? It is a very important parameter once we will be dealing with the DC circuits. So it is nothing but the resistance is nothing but the opposition that is offered to the flow of current. Once we are providing a voltage, due to the voltage there will be a current flow. Now the amount of current that flows, it will be resisted by the resistance. Now how much resistance is offered by the material? It depends on the type of material. What kind of material do we have? Suppose if we talk about here, we are having a material with a resistance which will be given as what? Rho L over A. This is the formula you must have read before in your previous classes, right? So it depends on what kind of resistivity the material is having, what is the area of cross section, what is the length of the conductor itself. So these values will determine how much resistance is offered by the conductor. So its SI unit is defined as ohm, and the symbol is capital R. Then second parameter is important, that is inductance. Inductance is the characteristic of an electrical conductor that opposes a change in current flow. Like the best example with which you can understand inductance concept is the transformer. Like this diagram here is representing a transformer, where once we are providing a voltage, suppose once we are providing an AC voltage, then what happens, due to the concept of the mutual induction, the coil that is connected on the secondary side, it also induces a certain voltage, although there is no connection, there is no physical connection between the primary and the secondary, okay. This is the primary one, this is the secondary one, so they are linked with the concept of induction. So that is what is written when a current flows through a conductor, because once we are providing a voltage, there is a current. So due to this current, what is happening? Magnetic field is building up upon the conductor, and this field contains energy and is the foundation for the inductance. So its SI unit is Henry and the symbol is L. Now two important properties of an inductor you can note down. The first one is no voltage will appear across an inductor if the current through it remains constant. So if we have a constant current, then it means there will be no voltage, and current through an inductor cannot change instantaneously. It will take time for an inductor to change the value of current. Then in the same way, we have another parameter, capacitance. It is defined as the ability of a device to store electrical energy in an electrostatic field. So how do we define the capacitance? Is like it is like a material where we are having two metal plates which are being separated by a dielectric material. and it can store the energy in the form of an electrical field. So its SI unit is farad and its symbol is C. Now what are the two important properties of the capacitance? The first one is that no current flows to the capacitor if the voltage remains constant. So if the voltage is constant, then there will be no current through the capacitor. And second one is the voltage across a capacitor cannot change instantaneously. It will take certain time for this voltage to change in a capacitor. So in inductance we have read current cannot change instantaneously. Similarly in capacitor we have read that voltage cannot change instantaneously. So these are certain formulas with which we can get maybe a small numerical based on the calculation of capacitance or the inductance. So the value of Q is given as C into V. So already we have read I is dQ by dt. So if you put the value of Q as CV over here, so we will get the value that I is C dV by dt. Similarly, the energy that is stored in the capacitor can be calculated as half CV square, and the capacitance of any particular material can be calculated with the formula A epsilon over D. Similarly, when we talk about the inductor, we have the formula V is L di by dt. So there it is again a kind of an Ohm's law kind of formula, and energy that is stored in an inductor is stored in the form of magnetic field, and the energy can be calculated with the value of half Li square. And the value of L for any particular conductor is given by this formula, that is mu n square A over L, where n is the number of turns and mu represents the permeability, A is the area of cross section and L is the length. Suppose we have a very small numerical over here. It tells us that you have to find the value of the capacitance if the value of voltage increases linearly from 0 to 100 in 0.1 second, causing a current flow of 5 milliampere. So if you will just see here, we have a formula here that tells us that if we want to find the current value, it is equal to C dV over dt, right? So if we put the values that are provided, so we have here 5 milliampere given, C value we need to calculate. Now dV is what? It is the rate of change of voltage, and that change is given that your voltage is linearly increasing from 0 to 100. So we can write it as 100 minus 0, that is 100 only, and that it is happening with the time period of 0.1 second. It means time is also given, t2 minus t1. So it is now a simple numerical where we have to just find out the value of C. So we will get C as 5 into 0.1 into 10 to the power minus 3, which is coming because of milli, divided by 100, that is 10 to the power 2. So you can see it will be 5 into 10 to the power minus 6, and minus 6 means micro. And we have a capacitor. Capacitor is having SI unit of farad. Okay, already this is given in our slide also. You can see SI unit of capacitance is what? Farad. So the answer will be microfarad. It is 5 microfarad. So option number D is the correct choice. Now once we are done with the basics of what is voltage, what is current, what is resistance and all, there is one very famous law that actually integrates these parameters, and that is an Ohm's law. Ohm's law states that the current in an electrical circuit is directly proportional to the voltage, that is I is directly proportional to the V across any conductor, provided that physical parameters like temperature, like pressure and all remain constant. So this is the condition. Now to remove this proportionality constant, we are using a constant, that is R. So we say I is equal to V by R, and R is rho L by A, that we have already told in the previous slide as well. So with this formula we can find out the unknown parameter. Now this table tells you, as I said, that resistance is given by rho L by A. Now how much resistance is offered by the material, it depends on the resistivity, and resistivity of different materials is provided in this particular table. So you can see, if suppose our material is a conductor, so obviously the resistance offered will be very less, their resistivity will be also very less. So its value, you can see, it is of the order of 10 to the power minus 8, which is a very, very small value. Then these are the best conductors, materials which can conduct conductors, they lie at the top. Then in between we have semiconductors, right? This is at the second category. So you can see the value is little bit higher on this side in terms of resistivity, And then we have say third category, that is called as insulator. So the insulators do not conduct at all. So you can see their values is in the positive powers, 10 to the power 10 for paper, 10 to the power 11 for mica, and so on. Now why this table is being provided is there, because you can expect a very small question out of it, like which of the following materials is a conductor, and they can give some options from here, some options from here. So you should be able to recognize what kind of material is the right choice. Then we have also calculated that power is V into I, and now we also know from the Ohm's law that I is equal to V by R, or we can say V is equal to IR. So if we put these formulas in these two equations, we can get alternate forms of power also. Okay, suppose if we put V is equal to I into R, right? So we get I square R formula. And if we substitute the value of I instead of V, so we can say power is VI, V is constant, and I is V by R. So we get V square by R formula. So it means all these formulas can be used to find the unknown parameters. Depending upon what parameters are provided, you can find out the values. And we have conductance also. Conductance is the reciprocal reverse of resistance. So G is the representation of this. It is denoted by G only, which is 1 by R. And R is what? What is R? R is V upon I. So we can say that G is I upon V. So this is I upon V. Then its SI unit is sometimes asked in the question, MCQ questions. It is Siemens also, and it is mho, means ohm being spelled backwards, and you can use the inverted omega symbol as well. Now one important concept is the concept of short circuit and open circuit. If suppose we are having two terminals and these two terminals are shorted together, so that means its resistance is 0. Okay, whenever we are having a short circuit, the resistance will be always 0. While as if suppose there are two terminals that are open, then the resistance will be always infinity. That is the first important point. Then in case of short circuit, because the resistance is 0, so the voltage across these two terminals will also be 0. So these two things are guaranteed if suppose we have a short circuit. Now in open circuit, R value is infinity, so the current across these two terminals will be how much? Current will be 0. So these two parameters are guaranteed, that whenever we are having a open circuit, then current will be always 0 and the resistance will be infinity. While as in this case, whenever we have a short circuit, voltage will be always 0 and the resistance will be always 0. Now the third parameter is current. Now because V is 0, R is 0, does it mean that I is also 0? Answer is no. I can be of any value. Okay, that will be more clear once we will do some numericals based on Thevedian and Norton, that current can be anything. Okay, I Norton is in fact defined as also as I short circuit current, so we will get certain finite value. Similarly here, when we have an open circuit, that does not mean that the voltage will be also 0 or infinite. The voltage can be finite of any value. Once we will be defining the Thevedian very soon, it is nothing but the open circuit voltage only across the circuit. So voltage can be of any value. Now we have one small numerical. Current can be of any value. For open circuit, you have to identify the right statement. So for open circuit, current can be of any value. Is it right? See, we know two things, that current will be 0 in this case, so this is wrong statement. Voltage would be equal to 0. This is also wrong, because voltage can be of any value, right? So this statement is right, 3 is right. Current would be equal to 0 is also right. So D and D option is correct over here. Now there are various applications of Ohm's law. So here we are only discussing that various parameters can be found out. In addition to that, there are some practical applications also, like if we observe the fan that we are using, that fan has a knob with which you can control the speed of the motor in the fan. So that is nothing but it works on the concept of Ohm's law. You are changing the amount of current that can be passed to the circuit. Similarly, all the heating appliances that we are using, they work on the concept of Ohm's law only. Or suppose if we talk about the power supply that is being designed for all the chargers that we are using, they also work on the concept of Ohm's law. So it is a very useful law. But at the same time, there are certain you can say limitations also of the Ohm's law. Like the first thing is Ohm's law holds true only for a conductor at a constant temperature, because that was given in the definition itself, that the temperature must be constant. Then resistivity changes with temperature. That is also a problem, that you must have read one formula that RT is equal to R0 1 plus alpha into T. So it means with increase in the temperature, the resistance is also supposed to get changed, which is a problematic thing. Then Ohm's law is not sufficient to analyze all the circuits. That also we shall see very soon. If suppose we are having a very small circuit where we are having certain resistors given like this, and you are being asked to analyze the circuit, we can do it using the concept of Ohm's law. We can say these two resistors are in parallel, this one is in series, and so on. Okay. But suppose if the complexity of the circuit is increased, suppose we have a circuit where we have a current source also. Now if I ask you to find maybe current or voltage, then it will be difficult to solve, because there are multiple sources. We cannot directly do the series parallel things over here. So that is why it is not sufficient to analyze the circuits, and that is why we have to study other things like KVL, like KCL, and Thevenin, Norton, etc. Then the next important point is it is not applicable to non-linear elements. What are the examples of non-linear elements? Suppose diodes, transistors, thyristors. In such kind of devices, what we observe that once we plot the VI characteristics, as you must be knowing also, then it is not a linear one. It is a exponential curve. Suppose in diodes you must have studied. In diodes, once we plot VI characteristics, it is the exponential curve. So these kind of devices do not follow the Ohm's law, because in Ohm's law what happens whenever we plot between voltage and the current, it is a straight line, as is shown here. So it is a linear. It means the way you are increasing the current with the same amount, the voltage will also vary. Similarly, the last point is that this law cannot be applied to unilateral networks. Now what are unilateral networks? Unilateral networks, and we are having one more term that is called bilateral. Example of bilateral network is a resistor. It means suppose we have a resistance. In the resistor, suppose we are connecting it in the lab also, we are not concerned about how are we using it in the circuit. Suppose A terminal is here, B is here, and then we are connecting it, or somebody is doing like this, he is doing it in the reverse way, B connected here, A connected here. In both ways this resistor is going to conduct. Okay, it's a bilateral, that's why it is called as bi. Now unilateral means they will conduct in only one way. Its example is again what? Diode. Okay, so if we are having a diode and you are providing a voltage in this way, it is a forward bias, so it will conduct. But if you are connecting this diode in a reverse way like this, and you again provide a voltage, now you see here it conducts, but here it will not conduct. So it is a unilateral network. So whenever we are having unilateral networks, then Ohm's law will not be applicable, right? So this is one simple question that you can try out by yourself. Then further applications of Ohm's law is we can find out the series parallel, and some basics I will tell you. Whenever the connections are in series, then what is the equivalent resistance is we have to simply sum them up. So okay, suppose here what is the total resistance, you have to simply sum all the value of resistances, and this is when all the values are in series, means the resistors are connected just one after the another, right? Then second is the parallel connection. The resistance can be connected in the parallel. If you see here R1, R2, R3, R4, they are connected in parallel. And how will you identify parallel connections? The golden rule is that they will be connected across same points. They will be connected across same points. Suppose this node is A, this node is B. So because there is a short here, there is no element connected. So this is also point A, this is also point A, this is also point A. So similarly they are all point B. So all the resistors are connected across A and B, so they are in parallel. In parallel, if we have to find the equivalent resistance, then what is the formula? suppose we talk only about 2 resistors at a time, then we say the formula is 1 by R equivalent is equal to 1 by R1 plus 1 by R2. So if we will solve it, so generally we remember like this, R equivalent is what? R1 R2 divided by R1 plus R2, right? So this formula we use to calculate the value of parallel resistors. Now you can see one very simple question over here. It tells you that the value of R1, R2, R3, if they are given in this way, how will we find? First of all, you have to see if we are looking for the resistance from this end, you will start from the opposite end. Now you can see these two are in series, so you will write first of all R2 plus R3. Then this equivalent that we got and this R1, they are in parallel, so this is in parallel with R1, so this will be the equivalent resistance, right? So that is being calculated over here. We will do certain questions based on it. Suppose this is the question, find equivalent resistance in ohms. Now see, we have to find R equivalent from this side, so we will start calculating it from 5 ohm, right? Now see, in first step, 5 ohm and 4 ohm and 3 ohm, they are all in series, so 5 plus 4 is 9, 9 plus 3 is 12, so 12 is the answer at first step. Now that 12 and this 4, okay, so we got the equivalent of these 3 as 12, so that 12 you can imagine here, so this 12 and this 4, they are in parallel, so what is 12 parallel 4? So you will use a formula R1 R2 divided by R1 plus R2, so it will be like this, so 4 into 1, 4 into 4, so it is equal to 3 ohm, right? It is equal to 3, right? So third step, now once we got until here 3, now that 3 and this 3, they are in parallel, okay? This 3 that we got here plus this 3 of the circuit, remaining circuit, makes it 6. Now that 6 and this particular 6 are in parallel, so 6 parallel 6. So whenever two values are same, the equivalent is the half of that, right? You can try it also, 36 over 6 plus 6 is 12, so it is equal to 3 only. Then in fifth step, what do we have? This resistance that we got and the remaining ones, they are all in series now, so 4 plus 3 plus 3, so this is equal to 10 ohm. So the answer of this question is B. So in this way, what is our approach is, whenever you are finding the equivalent resistance, you start from the opposite end and then you go on finding the series parallel combination, and you will be able to get the correct answer. In the same way, I will request you to just solve this question on your own. Now, as I said, Ohm's law is not sufficient to analyze all the circuits, so that is why we study the Kirchoff's law. And there are two laws of Kirchoff, one is KCL, other one is KVL, Kirchoff's voltage law. Now, what is the statement of the KCL? It states that the algebraic sum of all the currents entering at a node is 0. Or it also says that sum of entering currents is equal to sum of leaving currents, right? And it is based on law of conservation of charge. Okay, these are some important points of KCL. Now in this question, suppose they will ask us what is IT. So we have to consider the node. If you see these 3 points, they correspond to the same point, which is A. Alright, so imagine this is node A and all the currents, suppose I1, then I2 and then I3, they correspond to the same A, and IT is also going from the same. Now what is the formula we will use? I entering is equal to I leaving. So we have to see what are the currents that are entering. What are the entering currents? Entering currents are those currents that will hit the junction, that are approaching towards the junction. So those currents are I1 and I3, right? This is hitting the junction, this is hitting also the junction. But if you see IT and I2, they are moving away from A, right? You can see here also IT moving away, then this I2 is also moving away, right? So we can write here IT plus I2. So what is IT then? IT will be equal to I1, we have to transfer this term, minus I2 plus I3. So what is the answer? Answer is C in this case. Similarly, suppose we are being given this question, we have to find I naught. So again we have to select this node, then we will say entering currents is equal to leaving currents. What are entering currents? That will hit the junction like this 2 and this 4. And what are leaving currents? Those that are moving away. So they are 10 and I naught. So it is 6 minus 10. So I naught value is minus 4. So the answer is A. Now we have KVL. KVL states that algebraic sum of all the voltages across the loop is 0, or we can say sum of voltage rise is equal to sum of voltage drop, and it is based on law of conservation of energy. Now suppose we have a circuit like this, and I am asked to find out the voltage equation. So we have to follow the sign convention for it, and the sign convention I follow is, suppose plus to minus, whenever we are moving from plus to minus, we will take that term as negative, and if we are moving from minus to plus, then we take that term as positive. You can take the reverse sign convention also, you will also arrive at the same equation. Now because this is a closed circuit, we can start from any particular point. Okay, suppose we start from V1. So please note down how we do it. Okay, we are doing it in this way. We have to move clockwise or anti-clockwise. I am moving here, you can say clockwise. Now what I do, I will start with V1. So in V1 I am moving from minus to plus, so I will write plus V1. Now here I am moving from plus to minus, so it is minus V2, then minus V3. Then here I am moving from minus to plus, so minus to plus is positive, plus V4, plus to minus, here it is minus V5 equal to 0. So this is one form of equation. Or if we do like this, we write V1 plus V4 is equal to V2 plus V3 plus V5, that is also correct. So here what are we saying, that sum of voltage rise is equal to sum of voltage drop, and this is with the sign convention. So both ways we can get the right answer. So the answer of this question, law of conservation of energy. This question you can do by yourself. Now let us solve one question which is based on the KVL concept. Now here we are having two voltages that are given, 10 volt and 6 volt, and we are having 3 resistors. Across that certain voltages are also provided, V1, V2 and V3, and we need to find out their values, right? Now what is the approach of solving this question is, we will be applying KVL in both the loops, right? And accordingly we will get the values of currents and the voltages. So what we will write here is, we will write apply KVL in loop 1. So let us suppose this is my loop 1. Loop 1 is this one, okay, and this one is my loop 2. Now in this loop 1 I have to move, suppose clockwise, so I will move in this order. And what is the sign convention? I will repeat. If we are moving from plus to minus, it will be treated as minus, and if we are moving from minus to plus, it will be treated as plus, right? So we can write plus 10, then we can write minus 2I1 and minus 8I2 equal to 0, right? Or this can be also written as 10 is equal to 2I1 plus 8I2. So this is my equation number 1. In the same way, if we apply KVL in loop 2, then what will we get? And you can start from any one. So we are going clockwise like this, so we can write then plus 6, because we are going from minus to plus, and then we are going again from minus to plus, so we will write plus 8I2, and here we are going from plus to minus, so minus 4I3 equal to 0, okay. Or we can write 6 is equal to minus 8I2 plus 4I3. So what are we observing? We are having three unknowns, I1 also, I2 also, and I3 also. So we need at least third equation also, and third equation we can get from here, because if we see this node, let us call it as X. So we can write at node X we have entering current equal to leaving current. So we can say I1 is equal to I2 plus I3. So that gives us the third equation. So now it is all mathematics. We are having three equations, three unknowns. So once you will be solving this, maybe on calculator or using some method like Cramer's rule or the substitution method, you will get I1 equal to 3 ampere, I2 equal to 0.5 ampere, and I3 equal to 2.5 ampere. So based on that, we can get the value of V1, we can get the value of V2, and we can get the value of V3, because V1 is how much? 2I1, V2 is 8I2, and V3 is 4I3. So if you put the value 2 into 3, it is 6 volt. So 8 into 0.5 is 4 volt, and 4 into 2.5 is 10 volt. So we got the 6 answers that were desired. We got all the currents and we got all the voltages. So this is the approach we should follow once we are solving questions based on the Kirchoff's voltage law. Now these MCQs I am expecting that you can solve. For problem questions, we will see if we can have one more session where I can solve questions only, but here I am trying to give you the overview of the concepts, the theoretical concepts that we can use. Now there will be some topics like what is mesh analysis, what is the this nodal analysis. For that we must be clear about the topics, what is a node, what is a mesh. Those things should be clear to a student. So how do you define a branch? Branch is any particular element that is available in the circuit. Suppose if we see this particular circuit here, we have 10 volt, it is one branch, 5 ohm is another branch, this 2 ampere is one more branch, and so on. So we have total around 5 you can say branches in this particular circuit. Similarly, node is a point where 2 or more branches are meeting. Suppose at this point 2 branches are meeting, so it becomes a node. Similarly, at this point 2 or more branches are meeting, so it is a node. And what is a loop? Loop is any closed path. This is a closed path, this is also a closed path, this is also a closed path. So any closed path can be referred as the loop. Now an interesting question, how many branches, nodes and meshes do we have in the circuit? So for branches, just count the elements: 1, 2, 3, 4, 5. So we have 5 branches. Then how many nodes? So this is node 1 because they are same, this is node 2, and this is node 3. So we have total 3 nodes. Why this is all single node? Because in between there is no element. So in between, if suppose there is no element, so it will be considered as a single node only. So number of nodes are also 3. Then the third one is number of meshes. Now mesh is different from the loop. Loop is like if suppose we talk about the circuit here like this, and we have something like this, and let we call it as A, B, C, D, E, F. Now this A, B, C, D, E, F is a loop. A, B, C, D, E, F is a loop, but A, B, C, D, E, F is not a mesh, because loop is any closed path. So it is a general. Mesh is a closed path. It is a closed path inside which there is no other closed path, inside which there is no other closed path. So if we look here, so this is a mesh, this is a mesh, but the A, B, C, D, E, F as a whole is not a mesh. But A, B, E, F is a loop also. This is also a loop, and this is also a loop, A, B, C, D, E, F. Alright. So loop is a broader term, mesh is a smaller term. So in this circuit we have mesh 1, mesh 2 and mesh 3. There are only 3 meshes, right? So M value is 3. Now if suppose a question will be asking regarding how many loops, then we have these 3 plus we have 2 more. Okay, one is I will show you with this pen. one is this one. This is also one kind of loop. Okay, so this will be the fourth loop then. And similarly we can have one more that I can show you here, like these three. All right, so we have 5 loops in this. Okay, 5. Then this overall is also one more. Okay, so this is 6. So number of loops are 6. So L value is 6. So in this way you have to differentiate what is a mesh, what is a loop. Okay, and it is given here also in the slide. Loop is a closed path with no node passing twice. It's a simple closed path. But mesh is defined as a loop that does not contain any other loop within it. Okay, so this thing must be followed. Now in mesh analysis, it is basically a method that is based on the KVL, and once we write the equations, we normally get the currents out of it, right? And second important point is that mesh is based on planar circuits. Now what are planar circuits? It's a circuit that can be drawn in a plane with no branches crossing each other. If the branches are crossing each other, then it becomes non-planar. So let us understand planar, non-planar. If you see this particular diagram, means diagram number B shown here, all the resistors are shown without any two resistors crossing each other. So it is a planar circuit obviously. Similarly B also, all the resistors are very distinct, nobody is crossing each other, it is planar. What about the third one? Third one is an example of the non-planar circuit. Okay, the way we are having a resistance here, it will not be easy to move it away from the intersection point. If we look at this particular diagram, it may look it is a non-planar, but actually this is a planar circuit, because once we will redraw this, like this way very quickly, we'll try to redraw. So we have here and here. Now the problem is where? The problem is in the resistors that are inside. So what we can do, because they are connected between these 2 points, and similarly here it is connected between this and this point only, so we can take them from outside like this. All right, like this. So this is this 5 ohm that was going from inside, and this is the 6 ohm. So if you now visualize the circuit, all the resistors are distinct, so that makes this circuit as planar rather than non-planar. So these kind of things also you have to observe very carefully before you identify this as non-planar. Now this example is very clearly non-planar, okay, because you cannot separate out this connection and this connection, right? So they are intersecting actually. Now questions we will do on mesh analysis in the practice session, that we will have one more session on unit 1. In the same way we have the nodal analysis also. In nodal analysis, what we do, it is based on the concept of KCL. We are using it to find the unknown voltages, right? Like mesh analysis we have used to find what? Currents. This one we use for the voltages. Actually the concept is, once we will be using the voltage equation, we will convert that. Actually the concept is that once we will be writing the nodal equation, suppose I1 is equal to I2 plus I3, we will be using the Ohm's law, we will be converting this into V by R kind of equation. So in the same way we can find out the voltage, right? So in this session we will solve at least one question based on mesh analysis and the nodal analysis. So we have this question where we are being asked to find the mesh current. So in this particular question we have 2 meshes. This is mesh number 1 and this is our mesh number 2, right? Now what we have to do, mesh analysis, it is simply based on the KVL concept. So you have to simply apply the KVL, and what we have to assume is the mesh currents. So let us suppose we are assuming here current I1 and we are assuming here current I2. So here what will happen, both the currents will be flowing in the opposite direction, right? I1 and I2. Now what we will do, we will apply mesh analysis in mesh 1 first of all. We will write KVL in mesh 1. So in mesh 1 we will write following the sign convention that I told you, plus to minus will be minus, okay, and minus to plus will be plus, okay. So this we have noted down. Now we can write the equation that plus 7 minus, because we are moving from plus to minus here then as per the direction of current, because we should know this concept that suppose we have a resistor and current is flowing like this, so current will enter from plus, leave from the minus, so that makes this plus and this minus. So we can write minus 1 into I1 minus 2 times. Now in this 2 ohm resistor, it is a common between I1 and I2, so we have to write here I1 minus I2, because right now we are in mesh 1 is the reference, so I have to write 1 minus 2 rather than 2 minus 1. Then I will write minus 6 equal to 0. Okay, so that makes 1 equal to 3I1 minus 2I2. Okay, that is my equation number 1. Similarly, if we look at mesh number 2, you have to again apply the equation. So we can start from 6 volt, we will write plus 6 minus 2. Now because now we are in mesh 2 is the reference, so I have to write here I2 minus I1. Okay, so this is important in the mesh analysis, that how are we writing those currents which are common, like those resistor values where we have 2 currents. So check the reference value, that value you should write first. It's very simple. Then we have minus 3I2 minus 4I2, then we have this 9 volt battery also equal to 0. So once you will solve this, you will get 3 is equal to 2I1 minus 9I2. So these are the 2 equations. Now again solve equation 1 and 2, you will get the value I1 as 3 over 23 amperes and I2 as minus 7 upon 23 amperes. So this is the answer for the question. In the same way, let us have one question based on nodal analysis also. Now in this question, we have to find the current through 5 ohm. Now what we will do, we will assume here voltage V1, we will assume here voltage V2. So we can say that current across 5 ohm is equal to V1 minus V2 by 5, because I is what? V by R. So we can do like this also. Now once we apply nodal analysis, we should be clear about currents of each and every branch. Okay, suppose we know that this is a 3 ampere current moving upwards. Now after that, the current in 2 ohm and 5 ohm is not given, so we have to assume currents by ourselves. So we are assuming these directions I am giving randomly, and similarly here we can assume the direction, and this direction is already given as minus 2. Now what is V1 and V2? These are the nodes. So if you see this line, it is a node number 1. If we see here, it is node number 2. Why this is 2? It is because in between we had a resistor 5 ohm, and all the points which are at the bottom, they are all node number 3, and this is selected as a reference node. This is selected as a reference node, and reference node will be what? Grounded. So whenever we have a ground, it means its potential is 0. So voltage of the ground potential is 0. So it is known. So we just need to know voltage of node 1 and node 2, that is V1 and V2. Now what we will do, we will write like this: apply KCL at node 1. So once we will apply KCL at this particular point, so we will say that 3 ampere current, that is the entering current, is equal to one current is here V1 by 2, right, and the other current is V1 minus V2 by 5, right. So again you have to solve it like 3 is equal to, you can take 10 LCM, so you can write 5V1 plus 2V1 minus 2V2. So what you get, 30 is equal to 7V1 minus 2V2, right. This is one equation we got. Now similarly what we have to do, students, we will do like this: apply KCL at node 2. Now at this node 2, what we will do, we will again see entering and leaving current. So this current you can see is having this direction, so it is entering, others are going like this, so they are leaving. So we can write V1 minus V2 over 5 is equal to V2 by 1 plus this is minus 2, okay, like this, minus 2. So we can write V1 minus V2 is equal to 5V2 minus 5 into 2 is 10. So V1 minus 6V2 is equal to minus 10. So you can see now we are having equation 2 and equation 3. It is like two unknowns we have, two equations we have. So solving 2 and 3, okay, solving 2 and 3, we can get the value of V1 and V2 also, okay, V1 also and V2 also. So what do we have as value of V1? Once we will solve these two equations by any method, be it substitution, Cramer's rule, whatever you are comfortable with. So you will get V value as 5 volt and you will get V2 value as 2.5 volt. Now what you need to do, these values we got is fine, but we need to also find the current across the 3 ohm. So these values we will put in equation 1. So we will get I of 5 ohm equal to what? 5 minus 2.5 divided by 5. So it will be nothing but 1 by 2 ampere, which is nothing but 0.5 ampere. Now coming to the next topic, we have energy sources. So you should know that we are having a source can be a voltage source, right, or it can be a current source, which is represented by this symbol, right. Now voltage source can be dependent or independent. The example here is an independent source, and dependent is represented by a rhombus symbol like this, okay. Now dependent source, it can be also a voltage source or a current source, and it is dependent on what? It will be a voltage source, but it can be dependent on voltage or current. Similarly, if we are having a current source that is dependent, that can depend on voltage or current, okay. It means there are 4 cases, like we are talking about here, voltage source that is current dependent or voltage dependent. So it is voltage controlled voltage source or current controlled voltage source. Similarly, here we are talking about the current source which is dependent. So we are talking about the current source, so which it can be voltage dependent, so voltage controlled current source, or it can be current dependent. So these are actually the 4 cases of the kind of dependent voltage sources we have. Now what is a independent source, what is a dependent source? Let us understand that also. Suppose if we talk about a system where we have a battery and we have some circuit, right, like this. Now suppose this value is 5 volt, it means that all the time this battery is capable of delivering this 5 volt irrespective of what are the value of the resistors, right. If you keep on changing these values, so will this affect the battery value? Answer is no, because it is a constant. So they are independent. Same is the story of the current source also, which is independent. Now if we talk about the circuit like this, suppose we are having 5 ohm, we are having here one more, okay, diagram is not a bit clear, plus minus is here also. Okay, let me see if diagram is available. Yeah, suppose this one. Okay, suppose this circuit we will introduce somewhere in our circuit. Okay, we are having, suppose here one battery also, and this is 5I, where I is the current of this particular I can say resistor. Okay, considering this circuit, if I change tomorrow the value of this R, suppose this R value is 10, so value of 5I will be different, but if I change it to 100, its value will also change, because it is dependent on the value of I, and by varying the value of R I can change. So it means they are not having a constant value, its value can change as per the value of R being used. Now you can see here in this circuit also you can understand what are dependent sources. See, the value is what? This value is, it is a current source, because the symbol is current source, it is a current source. It is dependent on V, the value of voltage. So it is a voltage controlled current source, VCCS. So it is VCCS. And learn from this question what is a dependent source, how is it. Now see, this 6 volt, this 18 volt, they are constants. These values are never going to change whether you change the value of this resistor or this one or this one. But you see, this 0.25 Vx is a dependent source, its value is not constant. Why? Because if this value changes from 2 to 4 ohm, then Vx will also change. If Vx changes, then this value will also change. So that is how they are different. BJT is actually governed by the formula IC is equal to beta IB, where input and the output parameters are current or alpha IE. So it is a having, it is a circuit, BJT is a circuit where output parameters and input parameters are current. So we say it is a current controlled current source. So current controlled current source. Then we can also discuss voltage division. In voltage division, what we say, if suppose we are having multiple resistors connected in series, then in series current remains same. Okay, so current will not divide, current is same, but voltage divides. So voltage divides as per the formulas which are given here, right? How do you calculate these formulas? It is very easy. Just find out the total current and then find out the voltages. In the same way, we are having the current relations also. So you can use these relations and you can find out the voltage and the currents if suppose you are having multiple resistors. Now two important topics are left. One is Thevenin, other one is Norton. These topics we will cover in the second part of this video. Now the questions based on the voltage division rule and the current division rule will be discussing in the next part of the video, including some remaining topics like Thevenin theorem, Norton theorem, and the basics of AC analysis. So that's it for this particular video. I will be uploading the next video for the remaining topics. Okay, thank you all and have a nice time.